Alrighty, welcome everybody. Thanks for coming today. Today we're going to be talking about some of the research we have done around how to better interop tooling in supply chain security. My name is Hayden Blauzvern. I'm a technical lead and manager on Google's open source security team, where I'm focused on software supply chain security. And you might know me from the Sigstore community.
I'm Marcela Melara. I'm a researcher at Intel, where I have been leading software supply chain security research for the last 4+ years. I normally work in confidential computing and compartmentalization as well, and you can find me in all sorts of open source places. I am a maintainer of in-toto and SLSA. Those are pretty relevant to today's talk. So, yeah. So we'll be sort of covering 4 main topics today. I'm going to start with kind of an overview of the software supply chain tooling landscape, what that looks like, and several problems that we've sort of observed in the last just several years. Then we're going to talk about user journeys, especially around tooling, using tools, adopting tools, and what sort of challenges come up there. Then we'll talk about our notion of composability and integration, and we'll kind of say everything around what that means, and we'll end with a call to action. So this diagram may seem familiar to a few of you. I typically add in an extra layer, but essentially I like to split the software supply chain landscape into these 5 kind of technology areas, starting with the trust foundation at the bottom, which is what provides the integrity primitives, the crypto, the authentication, all the way up to policy and insight, which is how we really derive meaning from the metadata that's collected and aggregated sort of in these layers in between. And we'll be talking about a lot of the tools that I'm showing here, but I will not go through all of them. Hopefully folks here recognize what those are. So what problems have we observed in this landscape? Well, first, right, we can talk about formats. There are several formats that overlap. That's for better or worse, right? But even just looking at SBOMs, right, Cyclone DX versus SPDX, they're complementary, they're overlapping, and this can cause several challenges around choosing these different formats, but also building tools around them. Other examples that we show here that have overlapping data formats are Sigstore, in-toto, and DSSE, or Dead Simple Signing Envelope. And these, several formats also come with their kind of own specifications, their own frameworks, and so again, there are different specifications for different aspects, I guess, of software supply chain security, like signatures, attestations, provenance, and it's not always clear which one should pick and what tools should implement. And so in order to really support a very diverse ecosystem, we also end up with a swath of implementations for each ecosystem. And this kind of carries several other challenges, like burdens on maintainers, trying to really meet each ecosystem where they're at. And we're starting to see some, how should I say, like approaches to trying to facilitate or kind of reduce this burden on maintainers. So an example I'm highlighting here is the in-toto attestation framework that uses protobufs to really specify the APIs for generating in-toto attestations using, like I said, protobufs. Of course, protobufs themselves have several challenges that we have heard from downstream users. And so on the one hand, this has allowed us to not have to maintain 6 different repos. On the other hand, we have some integration challenges. And several of these kind of problems that I've mentioned kind of compound threat modeling. When tool adopters, users, and honestly even developers need to sort of understand and reason about the security problems that they're solving, not knowing which formats to use, having so many to choose from, having them overlap, can sort of raise questions around why are we using this tool in the first place? Which problem is this actually solving for us? Is this really just a compliance checkbox, or are we solving a specific threat? So yeah, Hayden will talk more.
So now we've seen some of the tools that organizations and users might use. We want to highlight a few user journeys where we have to make tooling or framework choices. The takeaway from these user journeys should be that there is no one right answer when it comes to picking different tools or different frameworks. But the choices that we make are going to have long-term impacts around technical debt or long-term maintenance. All right, so this is our one participation portion of the talk, so get ready. The first question that we want to ask is, how do you evaluate in your supply chain, or if you don't, how might you want to evaluate what dependencies are in your supply chain? So our first question is, raise your hand if you would use or you want to use an SBOM. All right, most of the audience raised their hands. Now, what about using an attestation to evaluate dependencies? So less, but still a good number, and I definitely see in the audience some folks raise their hands to both. And I think this kind of really underscores the point here, that SBOMs and attestations can be viewed as different. Some might view them as different formats, but they're solving a similar problem. So for example, we don't typically see attestations used in compliance, but we see both discussed as a way to identify and analyze dependencies. We see attestations being signed since there's common attestation formats that easily enable signatures. This is a great example of opportunities to converge between these two, not necessarily for all use cases, probably just for some. And we'll talk a little bit more about how we expect tools to be able to interop with one another in a moment. So another good example is how do you securely consume artifacts and dependencies in one's software supply chain. So you might choose guidance from NIST's SSDF or from the SLSA dependency track, which will be based on S2C2F. Users and organizations are presented with choices that may result in different tooling needs. And how do you validate your dependencies? There's many different ways that you can define policies. There's different tools and policy engines. You could look at something like Q or Rego or OPA, Kyverno. And once you select how you define your policy, how do you know what metadata you actually need to validate? Is it dictated by a standard, for example? And how should you pass along these policy results to other tools? Maybe you want to use something like a verification summary attestation or a VSA. So all of these questions are to highlight that organizations and users are faced with many different choices. And again, these choices can result in long-term engineering decisions as we bake tools and policies into our pipelines. So another user journey that I'm sure many of us have faced before is when your favorite tool or library is no longer maintained. So what can you do? Well, one obvious solution is just keep using it. But this, of course, comes with a risk of unpatched vulnerabilities. You could choose to fork it, but now you're taking on a burden around maintenance. So there's two other ideas that we want to present as well, and they'll tie into the rest of this talk. If you had to adopt a new tool that used a different format, what might you do if it can't be seamlessly dropped in? Well, you could build a converter where you're converting inputs and outputs between various tools, or you could build an abstraction, an interface that understands both formats. So this leads right into the next part of our talk, which is how do you integrate multiple formats and tools in an ecosystem into one's SDLC? As we thought about how to evolve the tooling in our own respective ecosystems, where we're both working on Sigstore and in-toto, we realized we needed a way to talk about how our tools and our outputs should be integrated and composed. And so we want to present composability and integration as two related strategies for interoperability. So let's define both of those. So when we say composability, we mean that an ecosystem provides building blocks for accomplishing a supply chain task. Each ecosystem will end up developing its own standards and tooling, but these tools are expected to take in roughly one standardized format and output roughly one standardized format. So what this means is that composition will require additional tooling to convert these inputs and outputs. We've included some examples here. There are many more. You can see some of these from our earlier slide as well around the tooling landscape. Another option is integration, which we define as tooling or frameworks that present opinionated views on how to compose other tooling. So typically we see these as larger monolithic systems. They'll grow in scope as more tools are introduced into software supply chain security. Again, thinking about inputs and outputs here, typically we might see something like many inputs, but one standardized output. There's a few examples here we wanted to highlight. There's some for provenance, such as Intel's Atlas framework or the in-toto witness project for provenance verification. And we also see Oracle's Macaron as a good example for supply chain analysis. So before we go into a comparison of composability and integration and how to build an ecosystem that has both, I just wanted to mention that Marcela and I went back and forth on our definitions of composability and integration. These are most certainly our opinions, and you might have a different view on these and how these are the same and different. So feel free to let us know if you have a different way that you would define these. So we'll start from tooling that is not composable and there's no support for integration. So this is likely where tooling is first going to start. You can iterate quickly and frequently break things without worrying about other tooling. As your tooling becomes more mature and stable, this is when tooling becomes composable. To get composable tools to talk to one another, you can build low maintenance, smaller dependency tools that transform outputs and inputs from one tool to another. Another path is towards integration, where a single tool may support multiple standards. We might expect, again, that these tools take in many different input formats and output a single output. So ultimately, the goal is to reach this bottom right box here, where we have both composability and integration. And this is where you have tooling within an ecosystem that is feature-rich, it's extensible, it's based on standards, and it's ultimately easy to use for users. So there's downsides with each of these strategies, and that come at each point in the development of our tooling in an ecosystem. Without composability or integration, there may be duplicated efforts across ecosystems. With only composability, where we need additional tooling to build SDLC pipelines, there's a risk to overburden maintainers with the maintenance of all these smaller tools. And the user experience suffers as users have to manage many different tools in their SDLC. With only integration, an ecosystem may lack standards, though even with standards, integration tooling must still be kept up to date as standards evolve. These tools are typically larger and they try to solve many different problems, and so these tools might be overkill for simple use cases. With both composability and integration, there's a high barrier to entry for users who might need to understand a myriad of different options. And while it might be obvious, standards can slow down development. Standardization is very much both a pro and a con for development. So we wanted to highlight what are some of the key issues when you have no integration or when you don't have composability within tooling. So we ultimately think that ecosystems need both of these. And without integration, users are faced with usability challenges. Even if we can compose tooling, users just don't want to have to chain together a bunch of CLIs and understand a lot of different inputs and output formats. On the other axis, we feel that composability is a requirement for interoperability. As we saw in the previous slide, you can have non-integrated composable tooling. It's a burden to users, but it's still possible to build. But without composability, integration isn't possible due to a lack of standardization. Trying to build integration tooling without standards places too much burden on developers, and there are still usability issues with the ever-changing features of our integrated tooling.
So ultimately, if this hasn't become sort of evident at this point, is that there is currently no one tool to rule them all, but we also don't think that this is necessarily a problem. So there's no right answer to the issues that we've been highlighting. Really, each enterprise, each kind of different application domain is going to have different requirements, and ultimately, there's no tool that's going to do everything or bridge all of the gaps that a particular organization needs met. We have observed that libraries are a great pathway towards integration. So several of the tools that we think offer some more of this composability and integration also offer libraries to go with them, and they are in ways built on their own libraries. And so in hindsight, this may seem like kind of an obvious conclusion, but we also still do see a lot of tools that don't provide libraries, and so this is maybe a helpful reminder here. We also kind of want to highlight, don't be afraid to pick multiple tools. Again, there is no one tool that can really solve every single problem, nor should there be necessarily. And so over the next couple of slides, I'll give a few more kind of specific examples of tools and frameworks that we think start to demonstrate this evolution towards composability and/or integration. So I'm going to start with TUF, or TUF++. This is the update framework. This is a framework for secure software updates for folks who are not familiar. There are several tools that are actually building around TUF. So I'm mentioning a few of the OpenSSF tools. GitTUF and RSTUF are two that come to mind immediately. So in addition to these tools, though, there are per language ecosystem SDKs for TUF. They provide conformance testing so that even when you are integrating, you can actually know that you are essentially compliant with this specification. SBOMs is another place where we've seen a fair amount of evolution towards composability and integration in the tooling. If we look at where SBOM started with the SPDX and CycloneDX specifications, that, again, were overlapping but not necessarily always clear which one was the more suitable choice for a particular use case. And not that either one is a better or worse choice, right? But there were format conversion issues that needed to be resolved. And so Protobom is a tool that actually handles this kind of bidirectional conversion and has simplified greatly interoperability between folks that use SPDX and folks that use CycloneDX, just simply by picking the minimum required fields in SBOMs that CISA has recommended. And then taking it one step further still at the level of SBOM usage, another OpenSSF tool that is trying to essentially bridge the gap between SBOM generation and SBOM analysis is BOMCTL that actually uses Protobom under the hood, again, showing this kind of composition and integration of tools. And I want to make a quick note about AI as well. We're starting to see a common approach in this space as well around AI and model supply chain security, where they are adopting and adapting existing tools from the sort of traditional software supply chain space for AI. And so some examples that we've seen here are model signing, that is built on DSSE and in-toto. For model provenance, the Atlas framework that Hayden mentioned earlier builds on model signing itself, further sort of in-toto features, and the C2PA specification, if you're familiar with that. And we also wanted to mention MCP and A2A here, because MCP essentially is this open source framework that standardizes how models communicate with other tools and software. So it's a way to compose a single agent out of multiple tools, out of multiple building blocks. And A2A then, again, takes that a step further and brings together multiple agents in a standard way. So hopefully you can see this kind of recursive application of composition and integration. And so essentially, to wrap up, we want to recommend a few kind of practices that we'd like to see more of. Stemming, as Hayden mentioned earlier, stemming just from our own challenges. I think cross-community collaboration is extremely helpful. It does require a lot of human-to-human interaction. It can be difficult to track down busy people, but it is so often worth talking to your ecosystem partners, especially for tools. Talk to each other if you have upstream and downstream relationships with different ecosystems. That can often take a lot of effort, but reinventing the wheel can often be counterproductive.
So the another recommendation is that we want you to think about not just generation, but consumption of the supply chain metadata that you're producing, right? Who is this data ultimately used for? How are they going to use this? Again, thinking about threat modeling, what are the security constraints here? Which kind of brings us to this last point, which is have a full end-to-end strategy. It will help to dictate not only what tools do we need to build, but what tools ultimately get integrated into the pipelines. And when we're talking about larger monolithic frameworks like integration tooling, we need to have this full end-to-end story in place. So ultimately, we're going to create ecosystems that are more composable and integrated. All right, that brings us to the end. Thank you all.
Thank you.
I think we have time for one question.
Thank you.
Hi, Santiago, Purdue University. I really like the framework of sort of composability, integration. I was wondering if there was a third axis that we're missing. I'm going to call it coordination, which is effectively like the overtime question of everybody's making local decisions, but there's no sort of like overarching technical guidance on how to evolve composability and integration. I don't know if this makes sense. I just wanted to fish for a reaction.
It does. I don't know. I'll take this question, at least the first part. This is a very informal framework, and so having input like what you just gave us, I think, is fantastic. And I think ideally, I mean, if someone wanted to go out there and actually formalize what we just presented, that'd be fantastic. But yeah, absolutely. I think things like coordination, automation are other areas that we didn't cover, but that's largely based on just kind of our own experiences recently around this kind of the challenges around the composition and integration pieces.
Thank you.